Hello friends and welcome to EntranceHacks. Today we'll be doing the final module on speed, distance and time of solving problems on circular motion and clock. So we know in a straight line motion if two persons are running in same direction they will never meet again. However, in a circular motion as in say a race, they are bound to meet sometimes. So concept of relative speeds is again applicable here, that is if they are traveling in same direction relative speed is s1 minus s2 and in opposite direction it is s1 plus s2. So let's start with first concept. So concept one is, when are the people going to meet for the first time? Meet for the first time. Okay, so let's say this is a circular track in which they have to run. Right, there are two persons A and B who are running. Let's say speed of A is s1 and speed of B is s2. So if they're running in a circle, so the faster person will meet slower person. You have to cover the circle to meet him, right? So suppose this B is the slow speed, so this might have traveled like this, right? And it has reached this point. However, at the same time, A was a fast one. He ran all the way to the circle, made all the round, and then again in the next round he met here, right? So this way they are meeting here. So relative speed here would be s1 minus s2, right? And distance which a person has traveled to meet is, suppose this B has traveled x distance and this A has traveled d plus x. D is circumference of the circle. So d plus x minus x is equal to d, right? So this person has to make a full one circumference to meet him. So the time when they meet for the first time will be d upon s1 minus s2, right? So they will be meeting here. Okay, so next concept 2 is, if more than two persons are running in a race. So if there are more than two persons in a race. Okay, so let's say speed of A is s1, speed of B is s2, speed of C is s3. Okay, now let's say A is the fastest runner. So relative speed of AB SAB will be s1 minus s2, right? And relative speed of AC will be s1 minus s3, right? So time taken by A to cross B would be, from our concept 1, it will be TAB is equal to distance upon s1 minus s2. Similarly, time taken for A to cross C will be D upon s1 minus s3, right? So at what time they three will meet together? It will be LCM of TAB and TAC. So all three will meet at the LCM of TAB and TAC, right? So let's take an example where TAB is, suppose A crosses B in 50 seconds for the first time, and T crosses C in 100 seconds for the first time. So when will they all three meet together? That will be LCM of 50 and 100. That is 100 seconds. So all three will meet at 100 seconds. Okay. Now coming to concept 3. Concept 3 is based on meeting at the starting point. So when will all three meet at the starting point? So concept 3 is meeting at starting point. So let's say there are three people who starts from this circle at this starting point. So A will take some time, B will take some time, C will take some time. So when will they meet again at this point? So this is calculated by using LCM of all three times. All three times. Okay. So let's say respective speeds of A, B, and C are S of A is 10 meter per second, S of B is 20 meter per second, and S of C is 40 meter per second. And this total distance they are covering is 1000 meters. So length of the track L is 1000 meters. So when will all three of them meet at the starting point? So time taken for A is 1000 upon 10, right? Time taken to B is 1000 upon 20, right? Distance upon speed. And time taken to C is 1000 upon 40, right? This will be equal to 100, this will be 50, and this will be 25. So LCM of these three times would be 100 seconds, right? So all three of them will meet at the starting point in 100 seconds. Okay. So now we'll go to the next concept. Concept 4 is the concept that how many times will they meet in the circular track, right? So concept 4 is number of times runners meeting in circular track. So there will be number of points you have to find when they are meeting in a circular track. So let's say speed of A is 25 meter per second and speed of B is 10 meter per second, and track length is equal to 1000 meters, right? So how many times will they meet in this circular track? At how many points are they going to meet, right? Suppose this is starting point, so they will meeting somewhere here, somewhere here, somewhere here, somewhere here. So we have to find how many points can they meet. So in general this is found by taking the ratio of speeds, and difference of the ratio of speeds is the number of times when they are meeting. So ratio of speeds here is 25 is to 10 is equal to 5 is to 2. So they will be meeting number of points of meet is equal to difference of this ratio, that is 5 minus 2 is equal to 3. So there will be 3 unique points in a circle where they will be meeting. Okay, now we'll move to the concept of opposite direction movement, right? So coming to opposite directions, so concept 5 is meeting for the first time. So it is similar to when they were traveling in same direction. Now when they are moving in the opposite direction, they will simply meet at time t, which is equal to distance, that is length of the track, upon an addition of speed, that is their relative speed would be s1 plus s2. They will be meeting at s1 plus d upon s1 plus s2 time, right? Now so concept 6 is meeting at a starting point when running in opposite direction. So this meeting at starting point will be same as in case of running in the same direction. So there is no change here. Same method applies. So we'll be taking LCM of respective times. LCM of respective times taken to complete the circle times. Okay. So let's say one person take t1 times, another take t2 times, another take t3 times. So LCM, whatever their LCM would be, that is the time when they will be meeting at a starting point. Okay. And now next concept is number of different points of track where they meet. Okay. Concept 7, number of different points in a track where they meet. So in case when they were moving in the same direction, it was difference of the ratio of speed, and when they are moving in the opposite direction, it is the sum of ratio of speeds. Okay, so let's say the same speeds are here, that s1 is equal to 25 and s2 is equal to 10 meter per second, right? So ratio of s1 is to s2 is 25 by 10 is equal to 5 by 2, right? So how many times will they meet in a track? It will be sum of the ratio, so that will be 5 plus 2 equal to 7. And remember, when we are taking the ratio, we have to calculate them in its simplest form. We cannot simply add 25 plus 10. It has to be in the simplest form. So 5 by 2 is the simplest form, so we'll be adding 5 plus 2 is equal to 7. Similarly, in the case when they were moving in the same direction, it has to be simplified, then only we can subtract to find this. Okay, so this was about circular motion. Now we'll be coming to important concept, which is concept of clocks. So clock can be understood as a circular track only. A clock is nothing but a circular track, right? And but what is the distance here? So let's say every minute distance is 1 kilometer, right? So total distance that hands cover when taking complete round is 60 kilometers, right? For a minute hand, it completes one circle in 1 hour. So speed of minute hand would be, minute hand completes one circle, so that is 60 kilometers in 1 hour. So it will be 60 km per hour its speed. Similarly, speed of hour hand, it completes one complete circle in 12 hours. So its speed would be total distance 60 km upon number of hours, 12 hours is equal to 5 km per hour, right? So speed would be this. This same concept we can also understand by the way in terms of degrees traveled. We know total degree in a circle is 360 degree, right? So total distance is 360 degree. So minute hand, speed of minute hand in terms of degree would be, it completes 360 degrees in 1 hour. Its speed will be 360 degree per hour. And speed of hour hand would be, it completes 360 degree in 12 hours, right? So its speed will be 30 degree per hour. So we can solve these problems in terms of kilometer per hour also, where we have assumed that 1 minute is equal to 1 kilometer, or simply in the form of degree also, right? So what type of questions can you face when using concept of clocks? So there are few concepts like type 1 question would be, let's say type 1. So the question would be, when will two hands of a clock will meet between two numbers? Meeting of hands between two numbers. So basically it is nothing but two racers running in a circle. So let's say it is 1 o'clock and we have to find when will hands meet between 1 and 2 o'clock. So between 1 and 2 o'clock we have to find, and current time is 1 o'clock. Right. So relative distance between 1 and 2 is 5 kilometers or 30 degree. So distance is equal to 5 kilometer, or in terms of degree 30 degrees, right? And relative speed is 60 minus 5, so it is 55 kilometer per hour, and in terms of degree it is 360 minus 30, that is 330 degree per hour, right? So this is the relative speed, this distance. So when will they meet? So time will be distance upon time, so it will be distance is 5 upon 55, or in terms of this it will be 30 upon 330, right? In both the cases it is coming as 1 upon 11 hours, which is equal to 60 upon 11 minutes, which is equal to 5 minutes and 27.27 seconds. This is general value which you can learn, and it can be used anywhere, right? So in a circle, clock hand will thus meet after every 5 minutes 27.27 seconds. So next time between 2 and 3, clock hands will meet at after 10 minutes, two times of this, so that will be 10 minutes and 54.54 seconds. So this figure we can remember. Next type of questions, so type 2 questions would be, that how many times will they meet in one round or 12 hours. How many times meeting in 12 hours, one round or 12 hours. Right, so it is simply, we know in a round there are 60 minutes and they are meeting after every 5 minutes, 27.27 seconds, right? So this will divide, it will be 11 times, right? So in 24 hours they will be meeting twice of this. In 24 hours they'll be meeting 22 times. So minute and hour and will be meeting these many times, right? Now next concept here would be type 3 problems. We know from above clock hands are meeting after every 60 plus, so clock hands are meeting after every 60 plus 5 and 5 by 11 minutes, right? That is equal to 65 5 by 11 minutes, right? So after this duration hour and 10 minute hands are meeting. So if we are given in a question, say that that clock hands are meeting after less than this much minutes. So if clock hands are meeting in say 65 minutes or any minutes less than this, so that means our clock is running fast, right? This will imply clock is running fast than normal. That's why the hands are able to meet before 65 5 by 11. And similarly, if clock hands are meeting in say 66 seconds, 66 minutes, sorry, that implies our clock is running slow. Okay. Next concept. So number of times clock hands are in a straight line is again every time the clock hands are meeting, it is 11 times, right? And they are at 180 degree, so in a straight line. So when are clock hands in a straight line? Either when they are opposite to each other or when they are meeting together, right? These two cases, and in both the cases it is happening 11 times. This is also happening 11 times. So total number of times in 12 hours when they are in a straight line. So a straight line would be 11 plus 11, that is 22 times. Similarly, number of times clock hand will be at 90 degrees. So there will be two cases. One, this is this way or this way. So again this will happen 11 times. This will also 11 times. So at 90 degree also they are 22 times. Right? So these were concepts on circular motions and clock. I hope you liked the video. Now if you have any questions on time and distance, post them in comments and I will provide you with solutions, video or otherwise. Till then, stay tuned. Thank you for watching. Please subscribe.